Alright, we'll see if this series converges absolutely or conditionally, or maybe the series just diverges. So here we go. When the question is asking us, does this converge absolutely or not, we'll first check the absolute value version of this right here. So let's go ahead and do the work. Here is to check absolute convergence. We just look at the series as n goes from 1 to infinity, and again, put the absolute value around the an part right here, which we have the negative 1 to the nth power over square root of n plus 1 in the absolute value like this, right? Okay, the absolute value makes negative 1 to the nth power just always 1, right? So we are looking at this as the series as n goes from 1 to infinity, and this is just 1 over square root of n plus 1. Does this converge or diverge? Well, it diverges because you can just do a real quick comparison with this one right here, right? So let's go ahead and do that real quick. So here is what we know, and let's just run through this real quick. We know that the sum as n goes from 1 to infinity, 1 over square root of n, which is the sum as n goes from 1 to infinity, 1 over n to the 1/2 power. This right here, the p is 1/2, which is less than or equal to 1. Therefore, this right here diverges. And then we can do a real quick check. Well, in this case, in fact, inequality is not going to work out. So we just do limit. It's much easier this way. So limit comparison test. Okay? So let's go ahead and put down as n goes to infinity. And put down the one that we're trying to do on the top. So we have the 1 over square root of n plus 1 over the one that we are trying to, the one we know, which is 1 over square root of n on the bottom. Well, go ahead and multiply the top and bottom by square root of n, square root of n. This and that will cancel. So we get square root of n over square root of n plus 1. Well, to take the limit, look at this and look at that. This right here will approach 1, which is greater than 0. So we get to draw a conclusion. And the conclusion is that this right here has the same conclusion as this. So we can say this right here also diverges by limit comparison test. So we are going to say bye-bye to the absolute convergence because the absolute value version didn't work. But we still have to check if with the negative 1 to the nth power, will the original one converge or not. So here we go. So let me just write this down right here again. And perhaps let's just rewrite it. This is the series as n goes from 1 to infinity, negative 1 to the nth power. And we have 1 over square root of n plus 1. In this case, as you can see, this right here is our Bn. And just go ahead and do the check for the alternating series test because the negative 1 to the nth power, right? So alternating series test. First check. Well, just take the limit as n goes to infinity. Bn is equal to 1 over square root of n plus 1. And we put infinity down in this n. Infinity plus 1 is infinity. Square root of infinity is still infinity. 1 over infinity will give you 0. So go ahead, just do that, right? Do a limit, so it checks. Then, second check. Do we have Bn plus 1 less than or equal to Bn? Meaning that is Bn decreasing. Well, check this out. Let's just go ahead and put the n plus 1 into this n, right? So that's pretty much what we have for the Bn plus 1. So we have 1 over square root of n plus 1, and then plus this one. Is this less than or equal to Bn, which is that 1 over square root of n plus 1? Well, cross multiply if you wish. This times that, which is just square root of n plus 1. This times that. Is this less than or equal to square root of n plus 2? Square both sides if you like, but you can pretty much see this is clearly true. This is so true, seriously. And just square both sides if you like. Again, be sure that you do enough algebra to convince yourself and convince people that this inequality is indeed true. Well, both of them are true. Therefore, we can come here and say what? This right here, this not also, because you just run through the alternating series test, right? So this right here converges by the alternating series test, right? So that's pretty much it. So that means what though? You see, the original version does converge, but if you have the absolute value version of it, didn't converge. So this is the conditional convergence, right? So know the definition and know what kind of check that you have to do. That's it.